In continuation with our previous video on magnetic effect of electric current part 1, here is part 2 for you. We recommend use of earphones for better audio quality and higher concentration. In this video we will be discussing the force on a current carrying conductor in magnetic field and the rule used to determine the direction of the force on the current carrying conductor in magnetic field. The rule is Fleming's left hand rule, which we will be discussing in this current video. Now we have studied earlier that an electric current flowing through a conductor produces a magnetic field. Recall Oersted experiment which we discussed in part 1, wherein we have a current carrying conductor and a compass placed near it. When current is passed through the conductor, the compass gets deflected, indicating that a force acts on the compass, that is magnet, due to current carrying conductor. Now here, if you use third law of motion, that is every action has equal and opposite reaction, we can conclude that the magnet must also exert an equal and opposite force on the current carrying conductor. In Oersted experiment, you have seen the force acting on the magnet due to conductor. Now we are talking of the reverse, the reaction, the force on the conductor due to the magnet. We can demonstrate this force using an activity which we will be discussing. In the diagram, you have a current carrying conductor, the rod AB, a magnet, U-shaped, horseshoe shaped magnet to produce magnetic field, a source of current, and a key. Let us suspend about 5 cm long aluminium rod AB horizontally by means of conducting wires, as you can see in the diagram. Place a strong horseshoe magnet such that the rod lies in the magnetic field directed upward. The magnetic field produced by a magnet acts from north to south, so you need to have the north pole vertically below and south pole vertically above the rod. Now this will mean the magnetic field acting from north to south is vertically upward. Connect the aluminium rod in series with a battery, a key, and a rheostat. The key will help us complete or disconnect the circuit to make the current flow or stop the current. And rheostat will control the current flowing through the rod AB. Let us pass current through the rod from end B to end A, that is directed into the paper or into the plane, and observe. I'm going to insert the key and observe what happens to the rod. The rod in this case gets displaced or deflected towards left, indicating that there is a force acting on the current carrying conductor AB towards left. This displacement confirms that there is a force. Now reverse the direction of current through the rod. The rod will now get deflected towards right, indicating that reversal of current also leads to reversal of direction of force on the current carrying conductor placed in magnetic field. So what is the conclusion from the above activity? Number 1, the displacement of rod in the activity confirms that a force is exerted on current carrying aluminium rod placed in magnetic field. The direction of force is reversed when direction of current through the conductor is reversed. Now let's try changing the direction of magnetic field. For this you need to reverse the positions of north and south pole. So you should see that the north pole now goes up above the conductor and south pole is vertically below the conductor. This will now produce the magnetic field downward. Again pass the current through the conductor and observe the direction of deflection on the rod or direction of the force. You will see that the direction of force gets reversed. So conclusion, the direction of force on current carrying conductor depends on direction of current as well as the direction of the magnetic field. You may change magnitude of current, you may change the strength of the magnetic field by using a stronger horseshoe magnet and observe the effect on the force. So experiments show that the displacement of the rod is maximum or the magnitude of the force is the highest when the direction of current is at right angles to direction of magnetic field. This you can study by changing the orientation of the rod. Keep it at 0 degree, 10 degree, 20 degree, 40 degree. Vary the direction of the rod AB and see the change in the displacement of the rod. You will see that the displacement is maximum when direction of current is perpendicular to direction of the magnetic field. In this particular case, the particular case we are talking about is current at right angles to direction of magnetic field. We have a simple rule which gives us the direction of the force on the conductor. Here we will be studying only the qualitative aspect of the force. We will not be studying any mathematical formula for the force acting on the current carrying conductor. The direction of the force is given by Fleming's left hand rule. According to this rule, stretch the thumb, the forefinger and the middle finger of the left hand such that they are mutually perpendicular. So here caution, you have to stretch the fingers, that is the forefinger, the central finger and thumb of the left hand. Always use left hand, do not commit this error of using right hand to find direction of force. The three should be perpendicular to each other. Once you stretch the fingers, in order to apply the rule in a particular situation, make sure that you don't bend the fingers anymore. You can use the motion of the wrist, you can rotate the arm but not the fingers. You can only align the fingers in the directions desired without bending them. So forefinger is not to be bent. You can change its orientation by rotating the wrist, by rotating the arm. If the forefinger points in direction of magnetic field, central finger in direction of current, then the thumb will point in the direction of thrust or the force acting on the conductor. Now here you have an aid to memory in order to minimize error in use of Fleming's left hand rule. See, F stands for forefinger, F stands for field. So forefinger should be in the direction of magnetic field. C for central finger and C for current. The central finger should be directed along the current. Then the thumb will give you direction of thrust, which also thrust is also alternative name for the force. Let us take an example here. You have an electron entering a magnetic field at right angle to the direction of the field. See the diagram. The direction of force you have to find out. So, various possibilities you have about direction of force, we have to choose the correct option. Recall that the direction of current is opposite to direction of motion of the electrons. Here the electron is moving downward, therefore the current will be flowing upwards. In order to find the direction of the force, you have to use the left hand rule, Fleming's left hand rule. Stretch the fingers as discussed earlier and is again shown in this diagram. The forefinger, the central finger and the thumb should be perpendicular to each other. The forefinger should point in the direction of the magnetic field. So, adjust the right hand so that the forefinger is towards right, that is the direction of the magnetic field shown in the diagram by means of 3 blue arrows. Adjust the central finger to be upwards. Caution, I am repeating, the fingers are not to be bent. You can use rotation of the wrist or you can change the position of the arms without bending the fingers. Adjust forefinger, the central finger along the arrows. The thumb here will point into the paper, which gives you the direction of force as directed into the plane of the paper or into the plane of the screen. So, the correct option here is the option 4 or option D. Now, here is a problem for practice. You have a proton replacing the electron. Now, here the proton being positively charged particle, the direction of current will be same as direction in which the proton is moving. You can find the direction of force on the proton due to magnetic field. Another example, the third, these are problems for practice. So, say if we elaborate here, we have a proton entering the magnetic field perpendicular to the direction of the force. So, since the proton is moving upward, the current will also be upwards. You should have in this particular diagram, you should have your forefinger pointing from left to right, that is along the direction of magnetic field. The central finger should point upwards in the direction of motion of the proton. You will see that in this situation your thumb points into the paper or into the plane of the screen. So, D is option again here. So, here are some more problems for practice. You will do well to solve these problems to reinforce your learning and master how to apply the Fleming's left hand rule to get the direction of force on current carrying conductor placed in magnetic field. Don't forget to subscribe to Physics Beckons and our YouTube channel for notification. Should you feel like providing feedback on the video, here is the email ID for your purpose. Happy learning. Thanks for watching.